Hi everyone, myself Karthik, Assistant Professor, Department of Triple St. Joseph Bootstrap Technology. So in last class we have seen problems based on mesh analysis. So now we will see some problems based on nodal analysis. So the problem given here is to find the current from the 15 ohm resistor in the network shown in figure by using a nodal analysis method. So we have two sources with 100 volt and 80 volt, and we have five resistors 20, 15, 10 ohms and 10 ohms. So we are asked to find the current through the 15 ohm resistor by using nodal analysis. So in nodal analysis, first we have to note out the nodes in the network. So always we can take a node where 3 or more elements are connected together. So if we look at this point, so here we have 20 ohm, 50 ohm and 10 ohm. So here this will be our first node. So let us take it as A. And here we have connected with 15, 10 and 10. So let us take this as our second node B. And if we look at this point, so here we have only two elements are connected. So this is a junction, it is not a node. And same as here, this will act like a junction, not a node. So in bottom, so we can connect all these points to the single point. So we can take this as other node, which is C. So totally we have three nodes here. So we can give the node potential voltage here. So let us take this as VA, let this be VB, and let this be VC. And since this is a reference node, so we can take this voltage potential as 0 volt. So this is the first point. We have to mark down the nodes in the network. And so here we can see the total number of nodes, which is equal to 3. So here we are going to solve this nodal analysis by using a inspection method. So the formula here for solving using inspection method is 1 by R into V, which is equal to I. So here we have to find the size of the matrix. So here this size of the matrix is n minus 1 into n minus 1, and for V it is n minus 1 into 1, and for I it is n minus 1 into 1. So we know that the total number of nodes here m is equal to 3. So here the value of R, that is the size of the R matrix, will be 2 cross 2, and voltage matrix will be 2 cross 1, and the current matrix will be 2 cross 1. So we have to find what is the value for 1 by R, V and I. So first let us solve the value for R matrix. So 1 by R. So we know that the value of R is 2 cross 2. So the elements will be R11, R12, R21, R22. And for V matrix, the voltages are VA, VB. So these are the two node voltages. And finally for current, it is, let us take it as IA and IB. So first we will find what is the value for R matrix. So first R11. So here there is 1 by R11. So 1 by R11, which is equal to the sum of reciprocal of all the resistor which is connected through the node 1. So this is our first node. So the resistor connected are 20, 10 and 15. So therefore it is 1 by 20 plus 1 by 10 plus 1 by 15. And next let us find for R22. So this is in the second node. So sum of all the resistors connected in the sum of reciprocal of all the resistors which is connected in the second node. So it is 1 by 15, 1 by 15 plus 1 by 10 plus 1 by 10. And next R 1 by R12 will be equal to 1 by R21. So here the node resistor which is connected between the two nodes is 15. So you can take it as 1 by 15, and this value which is always connected between the two nodes will be taken as minus. So this is minus 15. Next can find the value for current IA. So here IA, which is equal to, we can find from here. So this is our point A. So the current to this value will be the battery which is connected to it divided by the resistor through which it is connected. So here 100 volt source is connected to A and through the resistor value of 20. So therefore here it is 100 divided by 20. Therefore it is 5 ampere. And next we have to find the value for current B. So this is IB, which is equal to the source which is connected to the point B divided by the resistor to which it is connected. So here the source which is connected is minus 80. So therefore it is minus 80 divided by the resistor which is connected. Therefore it is minus 8 ampere. So we will be finding the value for VA and VB, and we can solve this by using Cramer's method. So we know that by the Cramer's method, we can write this is in matrix equation. So we have to calculate the value for 1 by 20, 1 by 10 plus 1 by 15. So the value is 0.216. 0.216. Next, 1 by R22, which is 1 by 15 plus 1 by 10 plus 1 by 10. And the value for this is 0.266. So it is 0.266. And next, R1 by R12 and 1 by R21, both are equal, which is minus 1 by 15. So when we solve, we get the values minus 0.066, minus 0.066. So the same value here, minus 0.066. So this is the value for R matrix. So here it is R into B matrix. So B matrix we know that, which is VA, VB, and it is equal to I. The value for I is 5 and minus 8 ampere. So 5 and minus 8 ampere. So now we can solve this inspection method matrix by using the Cramer's method. So by Cramer's method, VA will be equal to del 1 divided by del. So we have to find the value for del 1, and VB will be equal to del 2 divided by del. So first we will solve the value for del. So del matrix is the determinant of 1 by R matrix. So the value for 1 by R matrix is 0.216 minus 0.066 minus 0.066, and here it is 0.266. So this is the value for del. So we can find what is the determinant of this value. And next, del 1. We have to replace the current value in the first column of the del. So here it is 5 minus 8, and we have to keep the second column as it is. So minus 0.066, 0.266. So this will be the determinant value will be for del 1. And next, del 2, we have to replace this current value in the second column. So it is 0.216 minus 0.066 and 5 minus 8. So we have to calculate the value for del 1, del 2. So the value for del is 0.0526. 0.0526, and the value for del 1 so the value for del 1 is 0.802, and the value for del 2, it is minus 1.398, minus 1.398. So So we can find what is VA and VB. So VA will be equal to del 1 divided by del, which is 0.802 divided by 0.0526, and VB, which is equal to del 2 divided by del, it is minus 1.398 divided by 0.056. So we can solve this two value. So we'll get V1 as 15.25. 15.25. The value for V2, when we saw, we are getting minus 26.57. Minus 26.57. So here we are asked to find the voltage across 15 ohm resistor. So the voltage across the 15 ohm resistor, sorry, the current across the 15 ohm resistor. So the current across 15 ohm resistor we can find by using the value of current entering direction. We can take it here. So it is VA minus VB divided by 15. So we have a value for V1, VA and VB. So 15 ohm, VA minus VB divided by 15. So which is 15.25 minus of 26.57 divided by 15. Therefore, current across the 15 ohm resistor when we saw we get 2.72 ampere. 2.78 ampere. So this is the total current across the 15 ohm ampere. So initially we have solved this using inspection method. Finally we found the values by using gravel method. Okay. So here the second problem. So we are asked to solve by using nodal analysis to find the voltage across the 5 ohm resistor. So here in this circuit, so we have to find the voltage across this 5 ohm resistor. So in this problem, we have given with the voltage source as well as with the current source, and they have given 3 nodes. So A, B, C. So these are the 3 nodes which is given in the problem itself. So here we have to convert this voltage source into a current source. So in the first step, step 1, convert voltage source to current source. So when we have to redraw and we have to convert this to current source, and then we have to solve the problem. So we will first redraw the given problem. So here this 9 ampere, 4 volts, 2 ohm, this is 5 ohm, so this is given as it is. So this voltage source has to be converted to the current source. So the value for this resistor is 4 ohms. So when we convert this voltage source to current source, so we have to draw the current source in parallel with the resistor. So the total voltage given here is 12, and the resistance value is 4. So therefore the current value will be V by R, which is 12 by 4, that is 3 ampere. So the current value here will be 3 ampere, and we have to draw the resistance in parallel to the current source. So here the resistance value is 4 ohms. So first we have converted the voltage source to current source. So here we have to mark the nodes that is already given. So here it is A, this is B, and this is C. So let us solve this problem by using inspection method. So we know that by inspection method, 1 by R into V, which is equal to I. So first we count the number of nodes here. So this is A, B, C, and we can take a reference node. So totally we will be having 4 nodes. So the size of the R matrix 1 by R will be n minus 1 into n minus 1. So here it will be 3 cross 3 matrix, and the V matrix is n minus 1 into 1. So it will be 3 cross 1, and similarly for I matrix it is 3 cross 1. So we have to find the value for 1 by R. So the value for 1 by R, which is a 3 cross 3 matrix, so it consists of R11, R12, R13, R21, R22, R23, R31, R32, R33. So these are the value for R. We have to find out the reciprocal of all the resistance. So here first we will find what is the value for 1 by R1. So here 1 by R11, which is equal to the sum of reciprocal of all the resistors connected to node A. So here in this node A, the resistor which is connected here are 4, 2 and 4. So here it is 1 by 4 plus 1 by 2 plus 1 by 4. And next R12. So 1 by R12, this value will be equal to R21. So therefore it is 1 by R21, which is equal to the sum of reciprocal the resistance which is connected to node 1 and 2. So here between node 1 and 2 we have this 2 ohm resistor. Therefore it is 1 by 2. We have to take this value as negative. The next R13. So 1 by R13, which is equal to 1 by R31. So 1 by R31. So between node 1 and node 3, we have a connection here in the top, which is connected by 4 ohm resistor. So therefore it is 1 by 4. We take this value as minus. And we have already found 1 by R21. And next one, 1 by R22. So the sum of reciprocal of all the resistors connected to node B. So 205. So 1 by 2. 1 by 2 plus 1 by 100 plus 1 by 5. So this is for R12. And next R22, sorry. And next R23. 1 by R23, which will be equal to 1 by R32. So 1 by R32. Therefore this value is second and third. So no resistor which is connected between them is 5. So therefore it is 1 by 5. We take as minus. And next we have found this 1 by R31, 1 by R32, and finally we have to find that is 1 by R33. Therefore 1 by R33. The sum of reciprocal of all the resistors connected to node 3. So here this is point node number 3. So 5, 4, 20. So 1 by 5 plus 1 by 4 plus 1 by 20. So the value for 1 by R33. So now after solving we will get the value for 1 by R11, which is equal to 1 R12 minus 0.5. This is minus 0.25 and R22 0.71. Next one R23 minus 0.2, and finally R33 it is 0.5. So we'll get R11 as 1, R1 by R1 or 1 by R2 as minus 0.5, 1 by R13, 1 by R31, which is minus 0.25, 1 by R22 is 0.71, 1 by R23 and 1 by R32 which is equal to minus 0.2, and finally 1 by R33 which is equal to 0.5. So this is the value for 1 by R. So you can directly write here 1 by R is equal to R11 value is 1 and 1 by R12, R12 and R21 which is minus 0.5 minus 0.5. And next R13 and R31 is minus 0.25 and here also it is minus 0.25. Next 1 by R22 is 0.71. 0.71. Next 1 by R23 and 1 by R32 is minus 0.2. Minus 0.2. Here it is minus 0.2. And 1 by R33 here it is 0.5. So this is the value for R. And next we have to find the value for the current. So the current value, we have three currents. This IA, IB and IC. So when you look into the node A, the current in this node which is equal to the sum of entering currents and the sum of leaving current. So here you can see the entering current is 3 ampere and from this node the leaving current is 9 ampere. So 3 minus 9. So the value of 3 minus 9 which is equal to minus 6 ampere. And in node B we don't have any other current source or no source is connected to B. Therefore the current in node B will be taken as 0. Next in node C we don't have any source which is connected, but we have a current source which is entering into it. We don't have any voltage source. So the entering amount of current is 9 ampere. So since it is in entering direction, we can take it as positive, it is 9 ampere. So this is the current value. And next we can calculate what is the value for V matrix. So V is equal to VA, VB and VC. So by inspection method we have found the value for 1 by R, I and T. So now we can solve this by using Kramer method and we can find the voltage across the 5 ohm resistor. So to solve this by using Kramer method, we can find del and we can find the value for del 2 and del 3 because we have asked only to find the voltage across the 5 ohm resistance. So this 5 ohm resistor is connected between point B and C. So we can find the value for del 2 and del 3 and when we subtract we will get the value for the voltage across the 5 ohm resistor. So by Kramer's method, first we will find the value for del. So determinant of 1 minus 0.5 minus 0.25 minus 0.5 0.71 minus 0.2 minus 0.25 minus 0.2 0.5. So this value will be the determinant of del. So while solving this we are getting the value for del as 0.0956. It is 0.0956. Next we will find the value for del 2. So it is determinant of. So we have to keep the first and third column as it is and replace the value of I in the second column. So it is 1 minus 0.5 minus 0.25 is minus 6 0 9 and the third column minus 0.25 minus 0.2 and 0.5. So the value for determinant del 2 we are getting it as 1.125. 1.125. And next del 3. So we are replacing this current value in the third column. So 1 minus 0.5 minus 0.25 minus 0.5, 0.71 minus 0.2 minus 6, 0, 9. So we can find the determinant of this third one. So on solving, we are getting this value as 2.475. 2.475. So now we can find the value for VB and VC. So VB, which is equal to del 2 by del. The value for del 2 is 1.125 divided by del 0.0956. Next VC is equal to del 3 divided by del. It is 2.475 divided by 0.0956. So on solving this, we are getting the value for VB as 11.76 and the DC as 25.88. 1.76, 25.88. So we have to find the voltage across the 5 ohm resistor. So we can subtract VB minus VC. So voltage across 5 ohm resistor is VB minus VC, which is 11.76 minus 25.88. So we are getting it as minus 14.12 volt. So it is minus 14.12 volt. That is the voltage across the 5 ohm resistor. So we have solved this by using a nodal method and we have found the value for voltage across the 5 ohm resistor.